It doesn't matter.
You say way crazy. Let's recap last English class.
I do not. Yeah, Quinn, what's your
Okay, here we go. Good morning. We are on 7.6 Trig Applications. Oh, and we only have like 2 more topics to talk about here.
No.
Which means you have a test coming up next week. I am feeling the pressure. Okay.
Why are you feeling the pressure? You're not the one taking the test.
Because I have to have a whole nother unit ready for you to go.
No, you don't.
No,
you don't.
Yes, I do. All right. So, all right, I'm getting behind. We have some trig applications to do today. And again, applications are all about drawing a picture. All right. That's always, we need to draw a picture and really make sure that your picture makes sense. Read the story, visualize the story, draw the corresponding picture, okay? This is a huge thing. I went, when I got to college, like I was an avid reader. I read all the time, okay? I read Robin Cook, who writes medical thrillers, and all the time, huge books, lots of big words. I got to college and didn't know how to read. It's unbelievable. Weird, right? Get to college, I read something like, read a paragraph. I'm like, what the hell did that just say? And I had to go read it again. How many of you do that? Like, I read something. I don't know what it said, all right? I read something. I was like, I read the same passage 8 times, and I still didn't know what I was reading, all right? When you read, particularly a textbook, it's really, really difficult. You have to visualize. Create that movie in your brain. All right, when you're reading, that's what you need to do. You have to have a picture in mind. You're not reading words, you're seeing something in your brain. All right, and that's something you need to work on. Just as a general rule of life and your futures here, when you read, always have a picture. Okay, so today we're talking about 2 very special kind of trigonometry phrases. We are talking today about angle of elevation and angle of depression. And angle of elevation and angle of depression are phrases that signify very important things for us when we're creating pictures for our little trig applications today. So angle of elevation, we have a lovely little diagram here. This is Casey. Casey is standing outside a lighthouse, and he's looking up to the top of that lighthouse. Now, when we say Casey's angle of elevation, when we talk about angle of elevation, what we're doing is we're walking, right? When we walk, well, I guess some of you walk with your heads down looking at your phone, but normal people walk, and we keep our eyes straight, right? We're looking ahead so we don't run into anything, okay? So normally, when we're walking, our eyes are looking straight ahead, all right? Horizontal, parallel to the ground, all right? Excuse you.
Thank you.
When you have an angle of elevation, you are elevating your eyes and looking up, okay? So that angle of elevation is from horizontal, and you had to look up at something, that change from horizontal up, this little angle that I'm creating, is that angle of elevation. All right, so when you hear the phrase angle of elevation, there's always something horizontal, okay, parallel to the ground, but then the elevation is the angle created by having to look up, all right, changing the angle of elevation of your eyes, all right? So it creates some interesting stuff for us. So we want to draw and label a diagram and then solve for the missing part. Here we have a lovely picture of number 1. Casey sights the top of an 80-foot tall lighthouse. Here is the lighthouse, and it is 84 feet tall. At an angle of elevation of 58 degrees. Again, the angle of elevation is the change from if he was looking horizontally and he had to elevate his eyes, this right here is that 58 degrees angle of elevation. Casey is 6 feet tall. Casey is 6 feet tall right there. We want to know how far is he standing from the base of the lighthouse. So we need to know how far away he is. So you can see we've got this little triangle here, but you'll notice, does this triangle go all the way to the ground? No, it's from Casey's eyes where he's looking, all right? So ladies and gentlemen, I'm drawing this little triangle here from horizontally from his eyes and then to the top of the lighthouse. We have his line of sight here. What is this part of the triangle? Yeah, just right here. What is this distance right here? 78? How'd you get 78? Okay, yeah. Can you look at the picture and just assume that it's half?
Yeah.
Yeah?
Yeah.
Yeah. Pictures are never to scale. Okay. This lighthouse is 84 feet tall. You said that he is half. Yeah. No? Okay. So 84 minus the 6 that Casey is gives us 78. So this part of the triangle is 78 feet tall. And what we want to figure out here is how far away from the lighthouse Casey is. So we want the base of that triangle, that distance there. So looking at what we've been given here, we have an angle. What side is the 78? Opposite side, and then the x would be called the adjacent. All right, very good. And so we are using trigonometry. What's our mnemonic for trigonometry?
SOHCAHTOA.
SOHCAHTOA. All right, SOHCAHTOA. Now we've got opposite and adjacent. Which trig function are we writing? Tangent.
Tangent. Thank you. I had it right on the tip of my tongue.
The tangent of our angle of 58 degrees is opposite over adjacent, 78 over x.
Oh, wait, so
yeah. Yes, draw a picture today.
So we don't have to do much.
Yeah, the same thing. How do we solve for x?
Cross multiply. Oh, I know, divide by 58. Shoot, I don't know.
It's cross multiply.
Oh, yeah, right there.
Yeah, we're going to cross multiply. So we have x times the tangent of 58 degrees equals 78. And then how do we get x by itself? By the tangent of 58. You can't separate the two. The 58 is trapped inside that tangent. So they can't be, yeah. All right, so tangent of 58, we're going to divide by, it cancels out. And so in our calculators, what mode should we be in? Degrees. All right, is your calculator in degree mode?
Yes, ma'am. Garrison, it should be. You're not doing it right this time.
Some of them, they should default to radian. But so 48.7 feet. So he is 48.7 feet away. All right, let's try another. All right, number 2, we're going to read. The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? All right, we've got a kicker's foot on the football field. The angle of elevation to the top of the goalpost bars is 17 degrees. So here is the kicker's foot. And he is standing 131 feet from the base of the goalpost. So out here we have 131 feet from the base of the goalpost. Here's the goalpost. Hopefully they've not been pulled over. They are perpendicular to the ground. And it says the angle of elevation from the foot. So the foot is right here. This is his little foot. Maybe we could draw a foot there. There we go. There's his cleats. There we go. All right, there's his foot. The angles of elevation are from horizontal. So here's this horizontal thing, and the angle of elevation is what it has to go up. That is 17 degrees. And we get this little triangle, and we want to know how tall is the goalpost. What are we trying to find? The hypotenuse or this vertical piece? The vertical piece, yes, is how tall the goalpost would be. All right, which sides did they give us? Adjacent and opposite. So which trig function are we writing? Another tangent. Tangent of our angle is opposite over adjacent. How do we solve for x?
Tangent 17 degrees equals x over 131.
And then how do we solve for x? All right, so 131 times the tangent of 17 degrees. 131 times the tangent of 17 degrees. We get 40, maybe 0.1. And we are in feet. Okay. All right. Leah's mom is standing at the bottom of a slide at the playground, waiting for Leah to slide down. So we have a slide. Slides typically, all right. So here's the mom at the bottom of the slide. Oops, you can't see that. There you go. All right, we have a slide. Leah's mom is standing at the bottom of the slide, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees. So again, angles of elevation go from a horizontal and elevate upward. So from the bottom, looking up to the top is 46 degrees. The slide has a vertical height of 9 feet. So I have my right triangle. Where do I put the 9 feet? On the vertical part. So 9 feet. We want to find the length of the slide. Are we trying to find the hypotenuse or the base?
The base.
The length of the slide. How long is the slide? So do we want this piece or this piece? All right, we want the hypotenuse. That's what we're looking for there. Figure out how long the slide is. All right, which sides do we have information on? Okay, so which trig function are we going to write? It is not a sin. All right, sine is opposite over hypotenuse. All right, how do we solve for x? All right, so you get x times the sine of 46 equals 9, and then we need to do what?
Divide by sine 46. I almost said
Sine 46. Divide by sine 46. All right. So we get 9 divided by the sine of 46 degrees. So x equals 12.5 feet for the length of the slide. All right, any questions so far? Was pretty easy, yeah?
Yeah,
Get to it? No, not yet. A dog.
Are we good now?
A dog is standing 5 feet from the base of a tree. All right, I have a dog, and I have a tree. Okay, and he is 5 feet from the base of the tree, looking up at a cat that has climbed 16 feet up in the tree. All right, so the cat is somewhere here in the tree, and the dog is looking up at the cat in the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat in the tree? All right, what else do I need to label in this picture? Where does the 16 feet go? It's the tree, yeah, the height of the tree. So 16 feet, the cat is 16 feet up in the tree. All right, and then what is the angle of elevation? So where does x belong? It's an angle, and it's from the dog's eye. So the dog is down here. The angle of elevation must be this little angle. So we're looking for our angle this time. All right, what sides do we have here? All right, and which trig function am I going to set up?
The tangent.
Tangent of our angle, which is x. Tangent of our angle x is opposite over adjacent. Ladies and gentlemen, the x is trapped. How do we free the x? Inverse, tangent inverse of both sides. Easy peasy, just squeeze it in, and that's all you have to do. Mathematically, this is perfect. I know what you're doing. Tangent inverse of 16 over 5. To free the x, we get 72.6 degrees. Okay. We got to do depression, yeah. All right, turn the page. Okay. Angle of depression. So, angle of depression. Again, we have a lovely little picture right here. The angle of depression. Clayton, your pencil's on the ground. When looking down to an object. So again, here we have a picture of a lifeguard. Normally, our eyes are looking out horizontally parallel to the ground. But if you spot something and now you're looking downward, that change from horizontal downward is your angle of depression. All right? Going from horizontal, looking downward would be that angle of depression. And so it creates a very interesting Z shape for us. Look at this Z. Look at that Z shape. Tell me about that little Z shape. We have parallel lines because their horizontals are parallel. And so we have two parallel lines cut by a transversal. What do we know about this angle of depression? There's a congruent angle down here as well. So you get parallel lines and congruent angles. That Z shape is alternate interior angles. So this angle is congruent to this angle down here with that really interesting little Z shape. So those are important things to pay attention to. They might help. Draw and label a diagram and solve for the missing part, round to the nearest tenth. Excuse me. A lifeguard is sitting on a platform looking down at a swimmer in the water. So this is the illustration of this first problem. If the lifeguard's line of sight is 8 feet above the ground, what does that mean? Where does the 8 feet go?
The vertical.
The vertical, yeah. Because his line of sight is where the height to his eyes, all right? So from the ground to his eyes is 8 feet above the ground. And the angle of depression to the swimmer is 18 degrees. So right here, his angle of depression from horizontal downward is 18 degrees. That's not a 0, it's a degree symbol. All right. How far away is the swimmer from the lifeguard? We want the base. We want to figure out how far away that swimmer is from the base of this lifeguard tower.
Okay, we got to write down Sokotoa, Miss G.
Oh, okay. Sokotoa. Sokotoa. Always a good thing. It's trig. So I have my right triangle here, but my 18 is not inside the triangle. Is it? So we do have those parallel lines, alternate interior angles. So this angle down here, inside the triangle. In order to use trig, you have to make sure your angle is inside the triangle. Otherwise, you know, if 18 is only here, what would you call the 8 and the x? The 18 isn't inside the triangle. Where's the opposite? I don't know. All right. So that 18 is now inside the triangle, and because it's inside the triangle, what would you call the 8-foot side?
Opposite.
Opposite, and the x?
Adjacent.
Okay, adjacent to the tangent. Good.
8 over x.
Tangent of our 18-degree angle is opposite over adjacent 8 over x. And then how do we solve?
Cross multiply.
So x times the tangent of 18 degrees equals 8, and then we need to
Divide by tangent 18.
divide by the tangent of 18 on both sides. All right. So let's see. 8 divided by the tangent of 18, 24.6.
17.
Equals 24.6 feet away from the swimmer. All right. Let's go down and do number 7. I think that's probably the hardest one. Then we'll be done.
Yay!
Hooray.
You guys are hurting my feelings.
But that also gives you time to not have to do it. You gotta go do your own thing.
All right, building A is 480 feet tall, and building B is 654 feet tall. So I have, here we go, I'm going to draw building A. Right here is building A. It is 480 feet tall. So right here, this is 480 feet tall. And building B is 654 feet tall, so that's got to be taller. So I'm going to draw my building B right here. Building B is 654 feet tall. If the angle of the angle of depression from the top of building B. So here we are at the top of building B, and normally looking horizontally, but now we have the angle of depression is 42 degrees. So we're looking downward to the top of building A, and that downward angle is 42 degrees. So you need to have that horizontal there so that you can have something to reference. How far apart are the buildings? Well, ladies and gentlemen, I don't see a triangle. Do you?
No.
What do you see, Paxton?
Horizontal line.
Like from A across, or the, yeah, okay. So I can connect with the horizontal, so this is going to be a right angle. It's also parallel to this horizontal up here, all right? Okay, so now I see a triangle. The 42 is not inside the triangle. 42 turns into a hypotenuse?
The angle can't.
Alternate interior angles. Yes, I have my little 42 angle here, and I go parallel line, transversal, parallel line. So there's another 42 degree angle right in here. Do you see the little Z shape? All right, yes. Look for that Z shape. Now it says, how far apart are the buildings? So how far apart? We're trying to figure out the distance between the two buildings. So we're looking for that horizontal distance. What else do I need to know? I don't have enough information yet. The height. So here's my triangle. I'd like to know this height right here. How do we figure out that height? Good. So 654 minus the 480 gives me 174. So the difference from the top of building A to B is 174 feet. Now I have a triangle with what information?
Adjacent.
Opposite and adjacent. So we're another tangent function now. So tangent of 42 degrees equals opposite 174 over adjacent x. And then we need to? So we get x times the tangent of 42 degrees equals 174. And then? Divide by tangent of 42 degrees. All right, so the tangent of 42 crosses out good. We get 174 divided by the tangent of 42 degrees. And so we get 193.2 feet apart. Okay? Do you have any questions for me? All right.